This module of the online training for the ODOT Analysis and Traffic Simulation, or OATS, manual provides information on the analysis tool selection. In this module, you'll learn how to compare the two traffic analysis tools used by ODOT, differentiate between when one tool should be used over the other, and will understand situations in which Transmodeler should be used over HCS. The Highway Capacity Manual, often abbreviated as HCM. The HCM is the most widely used document in the transportation industry that contains a set of methodologies and application procedures for evaluating the capacity and quality of service of various transportation facilities. It is a tool for analyzing existing facilities and for planning and design of future systems. The HCM is built from more than 60 years of research work and represents a body of expert transportation consensus. Highway Capacity Software, commonly called HCS, is a computer program that implements the HCM methodologies. Both HCM and HCS analyze capacity and LOS for uninterrupted flow and interrupted flow roadways. Other travel modes covered by HCM and HCS are pedestrian, bicycle, and transit. Results from signalized intersection analysis created by HCS can be directly exported to Transmodeler software. Unlike the equation-based methods of HCS, Transmodeler uses microsimulation to analyze all types of roadway networks. Transmodeler uses car following and driver behavior logic to simulate the traffic operational behavior of various geometric conditions as traffic volumes and speeds fluctuate. Several measures of effectiveness can be obtained from the analysis, including some comparable to the methodologies in the HCM. While HCS and Transmodeler are both great tools for analysis, there are benefits to using one tool over the other. ODOT policy requires that HCS be used for all analysis except for conditions where HCS cannot adequately analyze project elements. A flowchart is provided to help analysts select the appropriate tool, as illustrated here. Each of these items will be discussed in more detail in the coming slides. The first question refers to analysis that are a part of PDP Path 5 projects or other high-profile projects. For projects under public scrutiny or where public involvement is critical to the success of the project, visualization may be helpful. With the analysis in Transmodeler, public-ready graphics and videos can be created to help the public and other stakeholders understand the proposed improvements and how they will affect traffic flow within the study area. When selecting the appropriate tool, it is important to determine if the study area contains any of the following features: mix of intersection control types, uneven lane distribution, oversaturated areas that are impractical to expand, and closely spaced intersections. Corridors often have a mix of intersection traffic control types. In some cases, adjacent intersections significantly impact each other. An example could be a signal metering traffic approaching a nearby stop-controlled intersection. Additionally, mixing roundabouts and signals on a corridor could result in queuing through the roundabout. In such situations, Transmodeler can be used to evaluate these effects. While HCS can account for uneven lane distribution, Transmodeler can measure the effects upstream of vehicles favoring one lane over another because of a downstream turn or lane drop. These situations include dual turn lanes, a lane drop a short distance downstream of an intersection, and interchange types such as a cloverleaf where a large portion of the traffic will be in the rightmost lanes. When project areas are oversaturated and it is impractical to expand the analysis limits to undersaturated areas, Transmodeler should be used. Lengthening the project area by several miles or multiple intersections is considered impractical. Transmodeler should be used to evaluate the queues between the intersections to ensure that they do not impact upstream signals. When selecting the appropriate tool, it is important to understand if the study needs to evaluate any of the following: system-wide measures of effectiveness, active transportation and demand management, also known as ATDM, strategies, interactions between vehicles and transit, and traffic rerouting. When system-wide metrics such as travel times, average speeds for the corridor, study area, and vehicle hours delay are being evaluated, transmodeler should be used. These metrics are especially helpful when the segment or intersection-specific levels of service does not adequately compare alternatives. For example, when all billed alternatives are LOS F, travel time or average speed may be a better metric for comparing between alternatives. HCS cannot accurately analyze active transportation and demand management, such as ramp metering, and should be analyzed using transmodeler. It should be noted that this type of application may be limited in Transmodeler SE and may require the full version of the software. Transmodeler should be used to accurately measure the effects of transit stopping in the travel lanes or receiving priority at signals. Using the origin-destination matrix in Transmodeler, traffic can dynamically be rerouted through the roadway network. This application is especially critical when improvement options close or change accesses to freeway segments or add new connectors that may shorten the travel time or distance for some drivers. While these traffic volumes can be manually rerouted, it is time-intensive when multiple alternatives are being evaluated, and it requires the analyst to make several assumptions to estimate the new paths. The analyst must determine if there are certain type of facilities present: interstate and arterial corridor interaction, alternative intersections, or weaving segments. HCS cannot analyze the interactions between freeway facilities and arterials. If the analysis of this interaction is critical, like measuring queue spillback onto the mainline freeway, transmodeler should be used. The results from transmodeler for complex intersections are more reliable than those from HCS. Such intersection types include diverging diamond interchanges, continuous flow intersections, R-cut intersections, five-legged intersections, and three-lane roundabouts. While HCS can evaluate weaving sections, transmodeler should be used to supplement the HCS results whenever HCS results in level of service F. When used to just supplement weaving sections, only the freeway direction containing the weaving segment and the weave itself should be analyzed in transmodeler. It is not necessary to model the entire traffic analysis area in transmodeler. If transmodeler is used for one alternative, it should be used for all alternatives, including no build conditions, to provide an equal comparison between alternatives. If transmodeler has been selected as the appropriate analysis tool and the entire project area is modeled in transmodeler, HCS analysis is not required. Both HCS and transmodeler can be used on the same project. If, for example, the project involved a freeway section with multiple interchanges but had one weave, the entire freeway network analysis could be done using HCS. Transmodeler can then be used to verify and supplement the results from HCS for the weave segment. The FHWA Traffic Analysis Toolbox cautions against comparing simulation results to the HCM-derived results. Rather, the analysis should review the software documentation to understand the differences and be sure that the micro-simulation software is calculating level of service properly. Based on discussions with the transmodeler software developer, Caliper, it was determined that transmodeler appropriately presents the level of service results consistent with the highway capacity manual methodologies. For basic analysis of mainline freeways, merges, diverges, and arterial intersections and segments, the results between HCS and transmodeler are consistent. For weaving segments, results can vary greatly between HCS and transmodeler. Therefore, all weaving analysis from HCS resulting in level of service F should be supplemented with transmodeler. In summary, HCS is required for all analysis except for conditions where HCS cannot adequately analyze project elements as detailed in Chapter 3 of the OATS manual. If transmodeler is used for one alternative, it should be used for all alternatives. If transmodeler is selected as the appropriate tool and the entire project area is modeled in transmodeler, HCS is not required. Both HCS and transmodeler can be used on the same project. All weaving analysis from HCS resulting in level of service F should be supplemented with transmodeler.